Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today. On January 1st, an investment account is worth $50,000. On May 1st, the value has increased to $52,000 and $8,000 of new principal is deposited. At time t in years, where t is between 4/12 of a year and 1, and 4/12 is the same as, of course, as 1/3, the value of the fund has increased to $62,000 and $10,000 is withdrawn. On January 1st of the next year, the investment account is worth $55,000. The dollar-weighted rate of return using the simple interest approximation is equal to the time-weighted rate of return for the year. Calculate t. And here's the solution. So first we note that interest earned in the account equals the amount at the end, which is $55,000, minus the amounts deposited, initial balance of $50,000 and $8,000 deposited, plus $10,000 that is withdrawn. So basically the depositor gets $55,000 at the end and $10,000 withdrawal out of the account and puts in $50,000 and $8,000. The net difference is $7,000. That's the amount of interest earned in the account. And we now equate the dollar-weighted rate of return and the time-weighted rate of return and obtain the following equation. $7,000, the net amount of interest, divided by $50,000 times 1, really, but it's $50,000 as a result. So $50,000, which was initially in the account, and we basically think about it as $50,000 that is in the account for a year, so multiply by 1, plus $8,000, which was deposited in such a way that it was in the account for 2/3 of the year, so that's why it's multiplied by 2/3, but $10,000 is taken out for a fraction of the year, which equals 1 minus t. That's why it's subtracted, because it's taken out, and it's multiplied by the amount of time that it was out of the account. That's how you treat the withdrawals. And that must be equal to the time-weighted rate of return, which is, we basically always look at the amount at the end divided by the amount at the beginning. So 50,000 went to 52,000, and 1 plus the rate of return, in this case, is 52,000 over 50,000, times the next period, 60,000 went to 62,000, so the ratio is 1 plus the rate of return for that period, times the next period, 52,000 went to 55,000, so the 1 plus the rate of return is 55,000 over 52,000. You multiply those out, you get 1 plus the rate of return for the whole year. You subtract 1, you get the time-weighted rate of return for that year. Those two are equal. This is an equation in which the only unknown is t, and we need to solve it. We calculate the right-hand side, and that comes out to be equal to 13 2/3%, or written as a fraction, 41 over 300. And so we write it out as 7,000 over 50,000 plus 16,000 over 3 minus 10,000 times 1 minus t, and this whole thing equals to 41 over 300. This is an equation with only unknown being t. We need to solve it for t. And so we solve it. We obtain 7,000 over 136,000 over 3 plus 10,000 t is equal to 41 over 300. Or 0.7 over, but just by dividing everything by 10,000 top and bottom, 0.7 over 13.6 over 3 plus t is equal to 41 over 300, and therefore t ends up being equal to 2010 over 41 minus 13.6 over 3. And you can just do this by taking 0.7 over 41 divided by 300 is equal to 13.6 over 3 plus t, just by moving the right-hand side to the denominator and moving the denominator to the right-hand side, which amounts to dividing both sides by 41 over 300 and multiplying both sides by 13.6 over 3 plus t. And therefore we solve it for t this way, and t is approximately equal to 0.5886179, which is answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.